class from today on Wednesday, 11/6, November 6th. First one we're going to take a look at, we're just doing some story problems on quadratic type functions and solving for the zeros. The first one I want to talk about is number 158. I did this one in front of our class today and could not, for whatever reason, piece it together as far as what was actually happening. And so we're gonna recap it here, and we'll rediscuss it again at the start of class tomorrow. But we're gonna talk about what's actually happening here for a second. So we're talking about being at the base of the canyon here, and we're gonna launch some projectile up into the air at 120 feet per second. And so what's gonna happen is this thing's gonna get launched. It's gonna actually go above the canyon, and then it's going to eventually have gravity bring it back down to the floor. And so the zeros we're actually solving for here are going to be the time value when it hits the canyon, the canyon wall, so the top of the canyon wall. And then once it comes back down and sees the canyon wall again. So in class today, we solved for those two zeros, but we really only looked at the second one when it was coming back down. So I just wanted to make sure we identified what was going on. So first off, we want to know when h is 0. And so this equation actually starts us 106 feet below the canyon wall, which is what the depth of this canyon is. So we're actually down here at kind of negative 106 in comparison to the height of the wall. So that's where this came from, and that's why our first x value is actually positive. As well, which was at like 1 second. And so let's take a look. So if I plug in 0 for our h value, we have 0 equals negative 16 t squared plus 120 t. So we have that initial velocity of 120. And we're fighting against gravity. That's what this 16 is in feet per second. And then we've got this 106. Okay, so that's the depth we're starting at. So then when I go to solve for this, I can plug it into our quadratic equation, which again is that negative b plus or minus the square root of b squared minus 4ac all over 2a. And so we just have to plug that in and chug through it. Some of you have it on your calculator. As long as you know how to program it and use it, I'm okay with you doing that. Use technology to your advantage, but understand why it works and how it works. And so when you type these in as your A, B, and C values, you should see that you'll end up with 1.02, I believe, is your first value, and then 6.48, if we round it to the nearest hundredth, for the second value. So basically what this is telling us is if I launch it from the canyon, it's going up at 120 feet per second with gravity fighting against it. So it's going to actually reach this height of the canyon wall at 106 feet in 1.02 seconds. Then it's going to blast way above and beyond the canyon for the next few seconds before gravity finally slows it down and brings it back. And then it'll cross that canyon wall again at the 6.48 seconds before it finally gets all the way back down and hits the floor of that canyon again, probably around 7.5 seconds or so. Anyways, wanted to make sure we address that, and that was why we actually will use both these times. The first time it reaches the height of the canyon wall is going to be 1.02, so that might actually be the answer we're going to be looking at for this one, depending on what's at. But those are both solutions when it will reach the canyon wall's height. So the very first time will be in a second time will be at 6.4 seconds. The one that you guys have for homework, which is 57, that one starts you at the top of a canyon and you throw the ball up, and then it falls all the way to the bottom of the canyon. So same idea, you're going to plug in the zeros, but you'll notice one of your solutions is negative, which we talked about in class, and it doesn't make sense to have negative time. So you'll just kind of ignore that solution, and you'll figure out that the ball hits the ground of the canyon or whatever, the top of the building, at the second, which I think is like 8 seconds or something like that. Next thing we're going to take a look at, and this is where a lot of the application comes in, we're going to be looking at cost, revenue, and profit, so a lot of business type stuff here. The cost of making bottled spring water can be expressed as such. The revenue is this. So we talked about revenue being the money we bring in for selling it, the cost being what we are paying out for making it. So profit can be written as cost or revenue minus our cost. So the first thing we looked at today was profit equal to revenue minus cost. And so as we took a look at this, we discovered that, yeah, we actually have added and subtracted equations from each other before, typically with elimination when solving systems of equations from the past. So if my revenue equation is negative x squared plus 326x minus 18,463, and I want to subtract the cost from that, which cost is expressed as 16x plus 63. I can subtract that entire equation from each other. So negative x minus 0, that's going to be minus negative x squared. We have 326x minus 16 of them. So we'll end up at 310x. And then we'll have negative 18,463 minus 63 more, so we'll be at 18,526, I believe. Okay, and then that becomes our new profit equation. So there's a flood that contaminates the drinking water of a nearby community. The owner, this is part A, by the way. We found our profit equation. The owner decides they want to bottle and donate as many bottles of water as they can without taking a loss. So when we take a look at this, most of the time you'll see companies that generate profit after a while, and then they'll eventually lose money if they make too much stuff. So we're going to take a look at these two solutions, and we'll try to find those break-even points. Well, if I want to bottle as many bottles as possible, that would be the smallest amount of bottles I could generate and be at a break-even. I'm going to be making money through here. This would be the most amount of bottles I could generate before I took a loss. So I want to look at profit being 0. Again, we can type this into the calculator and look for your zeros. Again, you're going to have to adjust your window so you can see it and then solve for the x-intercepts. Or you can type it into a quadratic formula, or completing the square. You can try to factor it, which would be really difficult. But let the calculator try to do most of the work for you. And so when you plug it into the equations, you'll see that x is going to equal 229.155. So if we think about this, because it's thousands of bottles, which I believe it tells us here, yeah, bottles in thousands, we could donate 229,155 bottles of water before we would have to take a loss as a company. So the last thing I want us to take a look at from the story problems we looked at today is the tennis court problems, because that one similar as far as trying to solve a quadratic, but a little bit different in setting it up. So we'll take a look at a tennis court situation here where you have a singles and a doubles court. I believe the one you guys will do tonight, which is 163, I was looking at the doubles court, and I will demonstrate the singles court. So a singles match is laid out so that the length is 3 feet less than 3 times its width. Got to be able to read that basically. So my length is going to be 3 feet less than 3 times my width. So I know 3 times my width minus 3 feet equals my length, essentially. Okay, length or width is going to be just defined as width. So we'll just use that as W. Now it tells me the area of the singles court is 2,100. So I know my area equals 2,106 feet squared. And I also know that the formula to find area of a rectangle is our length times width. So now I have an equation that has length defined in terms of width, so I can create an equation with a single variable. So 2106 is going to be equal to length times width. We'll distribute that through and get it all on one side. So 0 will equal 3w squared minus 3w minus the 2106. Okay? And as we type this into the calculator with your quadratic formula, you're going to see, and I haven't actually done this one yet because I was working on the one from class. So our negative b is going to be 3 plus or minus our square root of b squared. 3 squared minus 4ac all over 2a. So we'll see that we come up with x equals 27, or if we did the minus part of this, your other solution would be negative 26. And so similar to like we were talking about with the canyon height one, you're going to have a positive and a negative number. This doesn't actually make sense to have negative dimensions, so we're going to throw that solution out because it just doesn't make sense. And so we'll be able to identify that my width in this case, so W, is going to be 27 feet. I can then go and plug that back in to the length equation, and so we can figure out that 3 times 27 minus 3 is going to give us our length. So our length is going to be 78 feet. Okay, so there's our two solutions for our dimensions, and we can solve stuff like that. So go ahead and give that a shot. Hopefully it goes well tonight, and tomorrow we'll start looking for max and mins and vertex and stuff. So good luck.